Take a deep breath and allow yourself to settle into a comfortable position. This is a calm and gentle science story designed to help you fall asleep. Tonight, we're going to explore the story of the universe. A story that begins long before the Earth existed, long before the sun was born, long before any atoms, stars, or galaxies ever appeared. This is the quiet story of the Big Bang, explained slowly and softly, so you can drift off while imagining the universe unfolding around you. Let's begin far, far in the past. Imagine a time so distant that it doesn't even feel like a time at all. Scientists believe that the universe began around 13.8 billion years ago. But before that moment, we don't really know what existed. Some theories suggest that there was nothing. Others suggest that all the energy and space of the universe was compressed into a tiny, incredibly dense point. And some theories imagine cycles of expansion and contraction, where universes are born, grow, collapse, and begin again. But no matter which idea you prefer, the story begins at a moment called T=0, the beginning. At that instant, something extraordinary happened. A tiny point of unimaginable density suddenly expanded. It wasn't an explosion like a bomb spreading into empty space. Instead, space itself began to expand, stretching everywhere at once. There was no outside, only the universe itself, growing rapidly. In the very first fraction of a second, the universe expanded faster than the speed of light. This phase is called inflation. During inflation, everything smoothed out. Any tiny irregularities were stretched until the universe became extremely uniform. Temperature, energy, direction, shape, all became almost perfectly balanced. As inflation slowed down, the universe continued expanding, but at a calmer pace. Now, instead of sheer expansion, the energy filling the early universe began to transform. The universe was incredibly hot, trillions of degrees, so hot that no particles we know today could exist. Instead, the universe was a thick soup of pure energy. Gradually, that energy cooled just enough for the first tiny building blocks of matter to appear. These were fundamental particles like quarks, electrons, neutrinos, and photons. Quarks, affected by the strong nuclear force, began to group together. 3 quarks combined to form protons. Others formed neutrons. Electrons drifted through the energetic plasma of the early universe, but they could not attach to anything yet, because everything was too hot. Imagine a glowing fog of particles moving randomly, colliding thousands of times per second. As the universe expanded, it cooled further. After about 1 second, the universe had settled into a temperature where protons, neutrons, and electrons behaved more predictably. The protons and neutrons began to join together, forming the nuclei of the first simple atoms, mostly hydrogen and helium, with traces of lithium. This process is called nucleosynthesis. Even at this early stage, the proportions were set. Roughly 75% hydrogen and 25% helium, a ratio still found in stars today. But the universe was still a glowing fog. Light could not travel freely. Photons were trapped, bouncing from particle to particle, unable to escape. This continued for hundreds of thousands of years. Eventually, around 380,000 years after the Big Bang, the universe cooled enough for electrons to finally join atomic nuclei. When electrons combined with protons to form stable atoms, something extraordinary happened. The fog cleared. Light could finally move freely through space. This ancient light still fills the universe today as a soft, faint glow, known as the cosmic microwave background, the leftover afterglow from the birth of the universe. With the fog gone, the tiny variations in density, extremely slight differences created during inflation, began to take on a new role. Gravity, gentle but persistent, started pulling matter into these denser regions. Imagine small clumps forming, almost imperceptibly, slowly attracting more and more material. Over many millions of years, these small clumps grew into much larger structures. The largest became the seeds of future galaxies. The smaller ones would eventually form individual stars. Gravity works quietly, patiently, over immense stretches of time. Hundreds of millions of years passed. The universe was still mostly dark, filled with enormous cold clouds of hydrogen gas. But inside the densest of these clouds, something remarkable happened. Under the immense weight of gravity, the clouds collapsed inward. Pressure built, temperature rose, and deep in the hearts of these collapsing clouds, the first stars were born. These first-generation stars were enormous, far larger and more massive than the stars we see today. Their tremendous size made them burn fiercely and brightly, but also quickly. When their short lives ended, they died in spectacular supernova explosions. These explosions scattered newly formed elements throughout the universe: carbon, nitrogen, oxygen, silicon, iron, the essential ingredients for planets, oceans, atmospheres, and eventually, life itself. As more generations of stars lived and died, heavier and more complex elements accumulated. Over billions of years, galaxies began to take shape. Graceful spirals, massive ellipticals, chaotic irregulars. They formed galaxy clusters and even larger structures called superclusters. Across unimaginable distances, the universe developed a vast cosmic web, filaments of galaxies stretching like threads across the darkness. Our own galaxy, the Milky Way, formed more than 13 billion years ago. Over time, it grew larger as smaller galaxies merged into it. Within one of its spiral arms, a cloud of gas began to collapse under its own weight. As it contracted, the center grew hotter and denser until nuclear fusion ignited, giving birth to a new star, our Sun, about 4.6 billion years ago. Around this newborn star, a swirling disk of dust and gas slowly formed. Tiny grains began sticking together, forming larger clumps. These clumps collided, merged, and grew into planets. Among them was the Earth, small at first, molten and chaotic, but destined to become a home for life. But the story of the universe doesn't end here. Even now, billions of years after the first stars formed, the universe continues to expand. And not just expand, but accelerate. Something called dark energy seems to be pushing galaxies apart faster and faster. We don't yet know what dark energy is. It may be a property of space itself, or something we haven't discovered at all. But whatever its nature, it shapes the future of the cosmos. As time passes, galaxies drift apart. Stars burn their fuel. New stars form from the ashes of old ones. Over trillions of years, the universe may slowly grow colder and darker. Or perhaps a new kind of physics will emerge. Or maybe the universe will cycle into another beginning, repeating the process again. No one knows for sure. And that mystery is part of its beauty. Everything around you, every atom in your body, every breath you take, started in the first moments of the universe. The calcium in your bones was created in ancient stars. The oxygen you breathe was forged in distant stellar furnaces. The carbon in your cells was born in explosions billions of years before Earth was formed. As you relax now, imagine drifting weightlessly through the early universe, surrounded by soft, gentle light, carried slowly by the expansion of space. Imagine stars forming in the darkness, like tiny sparks flickering into existence. Everything is calm. Everything unfolds slowly, patiently, over unimaginable stretches of time. The universe is ancient, peaceful, and full of wonder. Allow yourself to rest within it, softly, gently, as you fall asleep.